today we're going to be talking about square roots. So when I think about square roots, I also have to think about perfect squares. So let's take a look at a couple perfect squares to see if we can figure out this general definition that's given to us here. So if I had 5 times 5, that's going to equal 25. A perfect square is when you multiply a number by itself. So then basically I can say the square root of 25 equals 5. Okay, because 5 times itself is equal to 25. That's the square root. All right, so similarly I can say 4 times 4 equals 16. So the square root of 16 is equal to 4 because 4 times itself gives me 16. So what happens then if I have something like this? B to the x times b to the x equals b. We know that's b to the first power, so let's try to simplify. B to the x times b to the x is really b to the 2x equals b to the first power. So if I'm trying to solve for x here, I can just take a look at these exponents. So 2x equals 1. To undo multiplying by 2, we divide by 2, and now x just equals 1/2. So the same way up here, where we wrote square root of 25 equals 5 and square root of 16 equals 4, we can rewrite the square root of b to equal b, and now instead of the x power, we know x is 1/2. So using that rule, now we can talk about the properties of square roots. So how can I prove that the square root of ab is also equal to the square root of a times the square root of b? This rule is going to help us with a lot of simplifying. So let's try again. If I have the square root of ab, I can rewrite that as that quantity ab to the 1/2 power. Using exponent rules, that would become a to the 1/2, b to the 1/2. And using the property that I just learned on the last page, that can be written as square root of a, square root of b. Perfect. So when I'm trying to break up problems with values in them, I'm trying to get values that are perfect squares. So are there factors of 72 that are a perfect square? So sometimes we don't really know what they are off the top of our head. So an easy way to do that would be to use a calculator to make a table. So I'm just going to list over here the values up to 8, and obviously you can keep going. So 1 squared is 1, and off we go. So when I look at the list here, I think about, okay, are any of these numbers in the x squared column a factor of 72? And yes, 36 is going to be a factor of 72. So then I can break up this square root of 72 into the square root of 36 times the square root of 2. Looking at the list again, the square root of 36 I know is going to be 6. So that simplifies to 6 square root of 2. Alright, so if we try it again for b, I have 2 separate square roots here, but they're being multiplied. So I can break them up individually if needed. Square root of 12. Well, looking again, 4 is a factor of 12. So this will get broken up into the square root of 4, square root of 3, and then I also have to bring down that last square root of 3. Square root of 4 simplifies to 2. And now square root of 3 times square root of 3. Square root of 3 in itself is not a very nice number, but that becomes the square root of 9. And we know that the square root of 9 is 3. So now it's just multiplication, and we get 6. So we broke up multiplication before. Now we're going to break up division. The same way that we dealt with the multiplication, we can deal with division. Square root of a over b can also become a over b to the 1/2 power. which then by exponent rules becomes a to the 1/2 over b to the 1/2, which simplifies to square root of a over square root of b. So now that we know this rule works, let's try a couple problems. So we can look at that same x squared list again, and we can break this up first into square root of 16 over square root of 25. Multiplication and division can break up like that. And then look right back at my list. I see the square root of 16 right here, so that's going to be 4 on the top, and I see the square root of 25, which means that's going to break up to 5 on the bottom. So really the square root of 16 over 25 is equal to 4/5. When we're talking about the square root of 3 over 4, that's going to get broken up into the square root of 3 over square root of 4. Now square root of 3 doesn't simplify. There are no values in our list that are factors of 3 that are perfect squares. So that's going to have to just stay as is. But the square root of 4 is 2. So the square root of 3 over 4 simplifies to the square root of 3 over 2. So lastly, we need to talk about square roots and variables. It's nice when we just have plain old numbers, but when we're talking about variables, sometimes we need to take square roots of those also. So the way I like to do it is I like to break it up. So the square root of 36, square root of x squared, square root of y cubed. So the first thing I'll do is I'll take a look at square root of 36, and I know that that's going to be 6. So the square root of x squared, we know, could really be written as x squared to the 1/2 power. So we're really just going to divide the exponent by 2. So instead of the square root of x squared, that's really just going to be x. Now the problem with y cubed is that it's an odd power. So we're going to need to break that up a little bit more. You are going to have the closest even power to your exponent in the first square root, and then just that plain old variable in the second square root. So this is going to simplify to 6x y squared to the 1/2 is really just going to be y, and then I can't simplify square root of y anymore. So that is my answer. So same idea up here. Let's break it down. Square root of 18, square root of a to the 3rd, square root of b to the 3rd. So thinking about that list again, that square root list that we have, I'll put it over here in the corner. I see that 9 is a factor of 18. So then this is going to break up into square root of 9, square root of 2. A is to an odd power. So the closest even power would be a squared. So square root of a squared, square root of a. Same deal for b. Square root of b squared, square root of b. Square root of 9 is 3. And then I'm going to look for the rest of the perfect squares that are going to get pulled out. So 2, that doesn't help me. Square root of a squared would be a. So I dealt with that. I dealt with that. Square root of b squared would just be b. So I dealt with that. And now the remaining square roots can all get bunched right together underneath that radical.